viewers. Thank you for all for being here with us. As I have already discussed that we will be going live due to some connection errors. We're just recording the session, and lately we will be able to send it to you, and I will be posting it live, or I will be posting a video of it on my Facebook and also on our YouTube channel, which will be a joint between Sohail, me, and my friends. See, the reason for using these sessions is to help the candidates who are having, they're not able to go to the school, they're not able to go to the universities, they're not able to go to the colleges. So all of us as friends, whoever I have been with in contact, we try to use these sessions. All of them are knowledgeable, and all of them are holding very good positions. That means they have a very good experience with the industry, and the knowledge will be shared with you. Now, more over, and I have already invited some of the CEOs in my past session on Zoom that was live telecasted, and we'll be doing all these sessions to help and to reach to the people with our experience, and with all the people who will join us. They'll be also joining to do these live sessions with us. So today we have Sohail with us. He's my friend. He has been with me in NIT Srinagar while we were doing the engineering. Later on, he went to his MTech from AMU, where he qualified with flying colors, and after that, he went to his PhD from IIT Roorkee. He has been the visiting professor to some of the universities and visiting scholar as well, some of the universities in USA, so University of Kentucky, I think. So let's hear from Sohail from now.
Okay, so
Sohail.
welcome. I'm thankful to Omar for this brief introduction. So, yeah, we know that in these times of COVID-19 pandemic, so online teaching and education has become, I think, a necessity. So we can, in this session, this is just an introductory session today. So I think we can use the online platforms for imparting the education and giving other information also related to job opportunities and other prospects. So I have, as Umar said, I did my PhD from the Indian Institute of Technology, Roorkee recently. So just I came back home, but I'm stuck here. But now because of this coronavirus pandemic, so even I could not get a job because of this coronavirus. I'm just stuck at my home. I think Omar has invited me today for this just an introductory thing. So it's a great initiative on part of Omar. So I'm happy to join here. So I think if more and more friends can join this session in the coming session, so this can become more interactive and we can have more good deliberations also. So that thing actually, I think this time we need to discuss and deliberate upon the things. There are so many things happening around the globe. So I think this would be a good opportunity for all of us to learn and to share the knowledge with each other. So we can then have more sessions also.
Let's go. Sorry to interrupt. That's cool. You have been very much. You have published a lot of papers, as I can see from your resume, which will be sharing for the experience. So most of your this expertise lies with the mass transfer operations. So we will be discussing about the mass transfer operations in this session, and lately we will be doing with the other sessions as well. So you will be taking mass transfer operations, and lately you will be doing the biochemical engineering part as well, right? So, Mr. Sohail, how did it happen?
Yeah, I have done my PhD in chemical engineering from in master. My expertise was in mass transfer operations. I was mostly working on stirred tank reactors. So as we know that stirred tank reactors, they are mostly used in the industries, in chemical industries. They are used in biotechnological industries and other industries. So they have got a lot of scope in the industries. So in stirred tank reactors, mostly the mass transfer, there is a mass transfer limitations inside the reactor. So you have water inside the reactor. You can have even some broth in case of the biochemical. When we talk of the biotechnological aspects, so you have a broth. So inside the reactor, the oxygen you need to actually supply the oxygen to the cells. So that's actually the main challenge, to supply oxygen. That's called oxygen transfer rate. So actually mass transfer coefficient, that we call KLA, so that comes into the picture. So we need to actually calculate the KLA, and we actually try to optimize and then do our calculations based on the mass transfer coefficient in order to scale up the reactors, so that at the lab scale we can have a small reactor. But if we want to then go for the pilot plant scale, or we can then go up to the industrial scale. So scale up of the reactor is a very important aspect, and mostly the study was related to the mass transfer aspects of the stirred tank reactors. Yes.
So, if, for example, we have in the once we're in the BTech level, we understand the mass transfer operations. So the session will be starting from the BTech level candidates and how we will groom them, how we will show them how are the aspects that we deal with industries on the industrial level about the type of the reactors or mass transfer operation that happen, and that. So how will you start, like from the very beginning, from your BTech level, or well, you're just communicating with the BTech level, then we have MTech, and we have finally the people either who go for the industrial kind of jobs, or the people who go actually for for PhDs and teach the students later on.
Yeah, like you said, mass transfer operations, like we can see there, it is a core and core chemical subject. So in the industries, most of the operations, like we have distillation. Distillation is one of the, we can say, the core this chemical operation. It's a mass transfer operation itself. There are so many other mass transfer operations which are used in the industry. So from the level of, if we talk about the level of the BTech students, so we have to first just let them, expose them to these simple mass transfer operations initially when we start this course. So mass transfer operations, we can have a simple, like we have a diffusion. If we talk about the diffusion inside a glass vessel, so like we put some amount of copper sulfate inside the water, so then we can see after some time the color of the water actually will change. So what is actually happening is that mass transfer is taking place from the CuSO4 copper sulfate to the water. So if we what happens is that the molecules actually try to diffuse inside the water. It will take some time. So we actually start from the level of the diffusion. So first we can say then there is convective diffusion and advective. There are different types of diffusion. So that's actually then comes the Fick's law of diffusion, where from we actually start. So then we have Fick's law and all those things. So I think that is from right from the scratch actually. So then there are so many different mass transfer operations. Like distillation is a very, it's a very well established subject. Now we can, it's actually most of the study in the industry, like petroleum industries or petrochemical industries, like most of the operations, like they are mostly distillation operations, where we are actually trying to distillate the crude or that thing. So I think that is, we have to start from this thing, and then we can actually go. And I think most of the industries, like separation, in case of the like uh, in case of the chemical process industry, separation forms around 50% of this whole processes. I think 50% of the processes are actually separation process industry, like related to separation, where we are doing separation operations. Like we have two things, like methanol and water. You can see methanol and water is a very good example of separation, methanol water separation inside the like in the industries. So most of the most of the we can say investment is done on the separation related equipment. So I actually want to separate the things in order to purify. We want to achieve 99% purity of the products, so that they can be directly then supplied to the markets. So separation, I think, plays a very important role in the chemical process industries.
Okay, so you I remember some of the experiments that we had done in our college, especially at the project level when we were just
Yeah,
doing the same project, but it was concurrent. You were just going with the I think with the biodiesel extraction from Jetropine I was doing from the
yeah,
algae. Yeah, it was good times. So I think at the time we faced some of these experimentations which actually help us in the mass transfer. But
yeah.
I think, how much do you think from your level when you were as a BTech student and then when you went to the mass transfer? So you think that there should be some more, part of the knowledge that I think you will be transmitting to the candidates who should be putting more efforts in the BTech levels to do this mass transfer operation than what is currently happening? Do you think that we have to do it more than what we're doing currently?
Yeah, I think like we have to actually try to improve the lab infrastructure first, and then I think like now most of the simulation softwares, like we have SPN, we have HiSys, we have there are different softwares also which are using, like when I was in NIT Srinagar after I finished my masters from the Aligarh Muslim University. I joined there as if you already know that I was there for 2 years working as a faculty contract faculty. So I tried to make the because during my master's course my master's was actually process modeling and simulation. So my project was also related to mass transfer. It was a hybrid process, like we have two processes like distillation and then a membrane separation. So we were trying to merge the two processes together so that we were doing it through a computer programming. So it was not an experimental like we were not doing experiments, but we are doing it through like computer program and all that. So uh, like most of the simulation softwares are also now available, like we have SPN. So when I was in NIT Srinagar, I tried to make the students also aware about the simulation softwares like the SPN, because no there were students in BTech, they were saying that they never heard of such softwares like SPN and all that. But when I was doing my masters, I learned this subject, this SPN. We had a lab, actually the design and simulation lab. So we were doing lessons every like we were exposed to some problem, simulation related problem, mass transfer problem. So then we were actually like doing these experiments using this simulation software. But it's a costly software, SPN Plus. You have to purchase it, and then you have to pay every year. You have to pay some money for its licensing to get that thing. So, but in IIT Srinagar, I have got a trial version of this software. So I was actually trying to teach the students SPN. I think most of the students, so many students were not interested, but few students who were showing interest, they used to come and they were actually, I used to tell them about the software. So I think software also, now knowledge of softwares is also very important. Like if you have concept, that's good, but the students should also be exposed to the software, because now the most of the studies, actually if you can see, most of the studies are simulation based studies. Like there are simulations going on, like if you have heard of a software is there, it's called ANSYS. ANSYS is a very powerful software. Like you are doing fluid flows, multi-phase flow and all those things, they are being captured using these ANSYS. Like you can see aerodynamics and all those things. So they are being done through this simulation software like ANSYS. ANSYS is a very powerful tool. It's being used in mechanical engineering, chemical engineering. So mostly you can do the multi-phase flow and so many other things are done in this software. So I think simulation studies are very, I think starting from SPN Plus, SPN Plus is a very good software. If a student is exposed to software, he can learn it. It's not that difficult software. It's like one can learn. You have to make the flow sheets and all those things, and then you can actually run the simulations and you can generate the results, which you can actually then see like at the industrial scale, like how much those results you are able to achieve actually.
Sure. And especially with the current, the future technology, depending on AI, so a lot of things will be changing around. And I think as a chemical engineer, once I left from the college, and I think you have a more experience in the chemical engineering than me, because I changed my field afterwards. I went into the management sector and industrial into the management. So I'm just checking how the level has been changing and how the technology is impacting the industry as such. And you have seen on the grassroots level. So I think with the advancement in the AI, I think there will be a lot of impact that will be happening at the BTech level. So if we have to start now from the student level, so they have to gear up right now at the BTech level to face the challenges that will be focusing in the, I think after maybe 5 years or maybe before that, there will be the impact and it will be seen
Yeah,
in the industries. So what do you think? In this session, would you like to incorporate this artificial intelligence impact on the chemical engineering and the mass transfer operation? Because I'm doing that thing in the for the management in the sectors that I'm taking, like LPP, linear
yeah,
programming
yeah.
problems that impact the industries and the transportation, and also in the you know, brand management. So I think it will be great from your side and from my side and from all the others who are putting an effort into this program to actually incorporate the AI view of the impact of AI, in fact, on on the studies and on the way that our juniors are going to come up and do their part.
Yeah, you are right. Like artificial intelligence, yeah, like we can say neural networks. So like artificial neural network (ANN). So it's a very good, yeah. It's also a very good tool. Now it's actually changing the things. So honestly speaking, I tried to use ANN during my PhD also, but like I was not able because I wanted to like get my PhD in 5 years, so I didn't want it to get prolonged for like then. But I tried to use ANN, but I think it's a very good tool. ANN, I really say it's a good tool. You can use it. So I will also try to like get more and more material regarding ANN. I will try. Even you can do it through. I think you can do it through MATLAB if you have MATLAB installed on your like desktop or laptop. It's actually. I tried to do some exercise also, but I didn't get much success. So I used ANN, but I was not able actually to do it finally. So then we have one more tool I think which I would like to say here because I use that. It's like RSM. I think design of experiments like response surface methodology. I think this is now mostly used. You can see so many paper publications actually coming out using this RSM technique. So response surface methodology I have also used during my PhD. So response surface methodology is kind of an optimization technique. Actually, you can optimize the things if you have got so many factors which are affecting some particular thing. For example, mass transfer coefficient in my case, it was being affected by so many parameters like agitation rate, airflow rate, temperature, and some other parameters also. So you can see like how these parameters are affecting mass transfer coefficient, which is affecting more, which is affecting less. So many such things you can actually study, and then you can come up with some new correlations, and then try to compare those correlations with the ones that are available in the literature already. So then see like whether your correlations are better. So this RSM I think also you can like this can be used. I think most of the students who are in the field of engineering, even the people who are in the field of this biotechnology and all that, they are also using this response surface methodology for like optimizing the parameters and then studying the effect of various parameters on some particular parameter which is our parameter of interest, we can say.
That'll be great, Sohail, while having you on board and giving your expertise and your efforts on the field. So we'll be doing these kind of a session. So if you can just for the students definitely and for the viewers who will be there with us, will be sharing their experiences as well. So it will be best for us if you will give your breakdown of your whole session plan to the students, if as we have already discussed, so they will know. And I think because it was an introductory session, and we will be going live on the Facebook, and we'll be going live with the YouTube, it will be the best that they will take the they will be knowing the timing and everything. So if it's required, if it's okay for you, because it's your time and your efforts, I value that much most. And the thing is that, do you think this 30-minute session is okay, or we should increase the session? Because I think you and me cannot concurrently focus on the same timing. So we have to be separate. Maybe you will be doing on the Friday, I'll be doing on the Saturday. So we will get more to know about from our viewers. But from your side, what do you think the best time will be for you?
For me, actually, I, I don't think I have a problem because, like as I already said, I am stuck in the room, so I have no problem. I think on Fridays, like in this at this time, I think it's okay. Like it's not a big issue for me actually.
Okay, let's for this once we finish our plan, let's publish the session planning with our viewers and all of them, and we
Yeah,
wish
even
them
I am
all of the best.
also
And thank you.
yeah even I am also trying to like like mm, make some lectures here like so that I can upload it on the on the YouTube channel. But like as you like know, here it's very difficult because the internet speed is also low, and the other thing is like you are here everything is locked down. So for
Let
that,
me tell all the viewers that Sohail is stuck up in Kashmir, and I am going the streaming from KSA. So there's a lot of problem that is actually happening because he's
yeah,
still using the 2G, because
yeah,
the government regulations, they're not
yeah,
allowing the 4G to go.
but
So
I think
I
still,
will be very fast and you'll be very slow. So that if you are having a problem with the buffering, so please, I I cannot say anything more than that. It is a part of the process.
I can say one thing, like the video is coming very good. I think you are able to hear me also clearly, but there is like
Yeah,
due to this 2G internet, I think there is some issue. But I think I told you I recently had a video call using the Zoom application with a professor from the USA. Like when I started the call, he was like quick to say this, that your internet connection seems to be like slow. So I told him that yeah, it's because of 2G internet, that this, otherwise if you have like 4G internet, you are able to see the picture very clearly, and like voice also will come very clearly. But I think still it is good, we have to manage the things, like we can't do anything. Like we have requested all the people to start the 4G, but I think it's falling on the deaf ears. Nobody is like ready to listen. There is nothing we can do about it. We have to just live with it. And you know
I understand. I understand.
the irony is that we are paying 4G. We are paying for 4G every month. Like we are plans that are being given to the companies, that are 4G plans. So they are charging 4G, but in return they are only giving 2G internet. So that you can see.
That's that's very bad.
Yeah.
Yes. So thank you for your session and thank you viewers for staying with us during this time. And I hope you all stay safe and healthy during this
Yeah.
pandemic. And
Yeah.
Love will come up very strong after this. Definitely, there are problems happening. Let us stay safe and stay healthy, and let us be not racist. Thank
Yeah.
you very much.
Thank you so much. Thank you. Okay. Bye.
Bye.